So, Eric, do you want to go into should we say a little bit about our goals? Let me talk a little bit about our goals. So, what we wanted to do today is we wanted to introduce you to some documents that we use. We'll talk a little bit more about them later. One thing I find when I work with teachers is that not everybody is really clear about what's actually tested on the TASC science. So one of our goals is to make you aware of exactly what is tested and how you can find out what is tested. And then we wanted to share with you a lesson that kind of models some of the best practices we think are good to use when teaching science. And then finally, we'll share some resources with you. So we thought we would start by going into breakout rooms very briefly. Eric, do you want to introduce that? You're muted, Eric.
Yeah, hi. So we're going to do a quick prediction guide. Some of you may be familiar with this warm-up strategy in a lesson, but we're going to use it with a few questions for you all as teachers. So we have a few questions for you to consider, and we'll just read them aloud real quick, but I also put them in the chat so you can click on them and have them available when you go into the breakout rooms. Kate's going to have them ready for us in a moment. So the statements, we want you to decide whether they're true or false based on your opinion. We haven't given you any information yet, or you're on your background knowledge, I guess. But students need to know why there is night and day, true or false. Students need to understand solstices and equinoxes. Students need to know why there are seasons. Students need to be able to locate the equator, poles, and northern and southern hemisphere. So think for a moment on your own, just about make a decision about whether you think each of those is true or false based on what you know. And Kate's going to put you in a breakout room for a pretty brief conversation where you'll just share with each other whether you think they're true or false, and maybe do a quick tally among the 3 or 4 of you in your breakout room.
If you have extra time, you might want to talk about how you know. Where do you get your information about the TASC science test?
Okay, opening up the breakout rooms now. Eric, I thought it would leave you out because you were a co-host.
Yeah, I think that's good.
Well, Kate, you and Kate technically were both assigned to room 4.
I'm going to do something terrible and move Lakshmi. Hopefully, it won't be too well. It's fine. It's fine. No, I don't want to do that. Hopefully, Kate's there. She can talk to the people who are there. That's fine.
Okay, sorry about that.
Yeah, it's totally fine. I mean, there's more. What else can you do? It's random, and then it takes too much time to be sorting people around.
Yeah. It feels like it should leave co-hosts out, though.
It seems like it should. That would be nice, right?
Yeah.
Or at least have an option, like you can click, right?
Yeah.
Leave out the yeah. I think I might go eavesdrop.
Okay.
Do you have a timer or something set for yourself?
I did not set a timer, but it's just 10:09 now, so I'll consider it 1 minute, and I'll pull everybody out at 10:13.
Sounds good. Though I think it takes a minute to close. Like
Okay.
there's a 60, so maybe I'm sorry to be crazy about this, but 10:12, is that okay?
Sure, absolutely.
Okay, thanks.
Sure. You're muted, Kate.
I was in room 4.
Yeah, it didn't. I thought it was going to keep you guys out because you were marked as co-hosts, and
Sure, everybody's functioning.
Yeah, I'm gonna go around as well.
can't hear you, Kate. I'm sorry.
I'm so glad it wasn't the 36 people who signed up.
Right.
I hate it when it's a ton of people. It's just,
Hi, Joshua. We're just in breakout rooms very briefly. I'm going to assign you to one. We've just got maybe 2 more minutes. And it is to discuss a quick, some ideas that are warm-ups for the TASC science section. So I'm going to assign you there. Please introduce yourself when you get there.
okay. Yeah, so everybody was able to access it.
I wonder how many latecomers we should expect.
So what happens when you're recording? Does it record what happens in the breakout rooms or not?
I don't think so. I don't think so. I think that would be very difficult.
Yeah.
All right, so I am going to close all rooms. It'll give them 1 more minute, and that
Okay.
will have been about 4 or 5 minutes.
Hi, Steve and Rebecca. We're just coming back from breakout rooms, so we'll catch you up here in a minute. Welcome back, everyone. So we wanted to hear a little bit about the conversation. So maybe we have time just for maybe a few comments, but maybe I'm just curious, was there any consensus on the first sentence? Students need to know why there is night and day. Any consensus on whether that was true or false in your group? You can go ahead and unmute.
True.
Anyone feel like that was false? And the second one, students need to understand solstices and equinoxes. Anyone say?
I agree with what
heads.
Vanessa put in the chat, is that they're all true, but the third one is sort of the most true, as in the other 3 are implied in that one. So like I've seen questions about students need to know why there are seasons, and you have to understand the other 3 in order to be able to explain that one. But I haven't seen so many questions directly about the others. But you need to know the others to be able to talk about, the reason for the seasons, or that is they're wound up in it.
Yeah.
Yeah.
So Lakshmi, you're kind of saying that the seasons one seems like a really important one, but the other ones are sort of foundational to that. Is that?
Yeah, you start with the others and you build up to the seasons, and the seasons is the one that will probably be on the test. But if you don't understand the others and you just try to memorize the reason for the seasons is the tilt of the Earth's axis or something, then you don't really get it. And I was relating to my group how I had a student this year who was convinced he'd gotten the Earth's orbit and the Earth's rotation completely reversed about what were the reasons for things like night and day. So exactly the questions we're talking about here. So you need them all, but the question that will really appear on the test is most likely the third one.
I
Interesting.
totally agree. I think that was very well said.
Thank you,
We
Eve and Lakshmi.
yeah, for my group, we also chipped in why day and night has to happen differently in different parts of the world. Like if I pick my phone in the morning in the US and call somebody in another continent, it's like this is their evening. Sometimes they've gone to bed. So, we also, think about that. Thank you.
Thank you, Esther. Can I ask, so I heard a little bit of conversation when I visited a couple groups, but I'm wondering, how do you know what's on the test?
I have the blueprints in front of me, and exactly the high emphasis is on Earth and the solar system. So I study the blueprints and make to-do sheets based on those blueprints if I boil them down to lessons or topics.
Yeah, it's the same basically with me when I was teaching the class science. The blueprint is what I believe will be in there, and then I have to go into the high emphasis area because I believe that is where students could get more score. And then we do a lot, and sometimes I have to give out project topics on the high emphasis area, and students, when they make research, okay, some things tend to stick with them because they have done that for several years, several days before, they do the presentation. Yes, I do that.
Thank you, Esther. Your audio is it's a little bit clippy, so it's a little hard to understand, but some of what I heard is about knowing what the high emphases or high emphases are on the test. Eve, you were also talking, I think, in the group about the framework. Were you talking about the framework for science education?
I'm sorry, blueprint would be a better word for that. I misspoke. I meant blueprints. With the outlines that say what is high, medium, implied skills or emphasis.
Got it. Thank you. So I guess part of when a few years ago, I don't know how many years it's been now, but when we got the task after the GED, and as the task started to develop or continue to develop, we at CUNY, we're trying to make sense of what it was that students needed to know on all parts of the exam, but especially the science, because suddenly students need to know a lot of content. And so, one of the things that we did is we looked at practice tests, the readiness exams to make, see what the actual test questions could look like.
Right.
And so this is a sample question. We're going to look at some other stuff as well, but this is a sample question here. It's part of a sample question. It's not the whole question. You might even recognize it. I'm wondering maybe in the chat, if you could read it to yourself real quick, and then in the chat, could you make a guess about what you think the question actually is? The question's missing. So what do you think the question is? What could it be? Here's some good questions coming in. What is the date on the X in relation to October 21st? What season will it be when Earth is at the X position? How long does it take for the Earth to orbit the sun? What season in the Northern Hemisphere? At what date do you believe the Earth will reach X? So you see, I just revealed the actual question, but it seems like almost any one of these could be the question. How long does it take for the Earth to orbit the sun? What will season be when the Earth reaches X? So now shift a little bit, a different question for you. What do students need to understand in order to make sense of this question and this diagram? So also in the chat, if you wouldn't mind, what are some of the things that students need to understand?
What background knowledge do they need?
relationship of the seasons to the Earth's orbit, rotation versus revolution, equator dividing hemispheres, how the Earth's orbit works, hemispheres in relationship to the seasons, yeah.
I like the planets in this solar system orbit the sun because it is basic first step information to lead up to some of these other things.
Hmm.
Yeah, so there's a lot. Look at
It's kind of amazing how much is inside this one question. So this is kind of what we were doing when we were looking at the questions and trying to think backwards and what's foundational to the understanding. And then we were also looking at the learning standards themselves from the blueprints, from the next generation science standards, or, and how they made their way into the TASC learning standards. So this is a learning standard for, this is, I mean, again, it's Kate and I's best guess, but it seems like this is the learning standard for this question. Use mathematical or computational representations to predict the motion of orbiting objects in the solar system. So, but what does that mean? Does anyone feel like you have a sense of what that means and put in your own words? You do this verbally, you don't need to type it. Or what are some of the things that this refers to? Or did we already, is it just all the stuff we've already talked about maybe?
Maybe a basic visual of how the sun and the planets are lined up and what direction they're going.
Mm-hmm.
I've seen practice questions with that exact diagram.
Right.
Maybe understanding and calculating the length of time to move from one season to another, or one period of time to another, and also how that's different for different planets.
Mm-hmm.
And maybe adding the moon in there.
Mm-hmm.
Right. So, Kate said this learning standard feels a bit general and vague, and as a teacher, she wants more details. And so that, that was kind of what we were feeling at the time, that the learning standard, I mean, I suppose it identifies the piece of knowledge, but it doesn't really help me know what to teach quite. So we were trying to make sense of what do we actually need to teach. And so we did this for math as well, and that's actually where we started, was making sense of the math test. But for science, what we did is we looked at the TASC readiness exams, we looked at the DRC, the publisher for the TASC, we looked at their item specifications, which were actually based on the next generation science standards, but they were edited. They picked and chose a little bit about what they wanted to include. And then we created these documents that we call detailed descriptions and sample items. And they're really supposed to be guidance for teachers. They have practice test questions and a short explanation of each of these science learning standards. So I just want to briefly just give you a glance at what they look like. They're fairly long. You should be seeing a Google Doc now, is that true?
Yeah.
So you'll see that these are the same categories as, for the earth science, it shows that the 25% that is earth and space sciences is split up into these three categories of earth, place in the universe. There's systems, earth, and human activity. And then each of the learning standards are in here. And then there are, so here's the learning standard, the first one. And then there are some sample questions that are related to that learning standard. And then, our best guess at what this really, what are the key ideas here that are being tested? And as accessible language as we could. I mean, it's written for teachers, not for students. but just so we can really understand like what is being tested here. So this first one, for example, develop a model based on the evidence to illustrate the lifespan of the sun, the role of nuclear fusion. You have a bunch of questions here about the answer almost is always nuclear fusion, by the way, but what are the key ideas? Like, where does the energy in the sun come from? And hydrogen is the sun's fuel. And so the framework for K through 12 science education was very useful. I have it referenced here at the beginning. This link right here is actually a very readable document. It's prose, it's explanatory, it's not just learning standards. But we used that and we sort of summarized it and took some stuff from it. Anyway, so this is all here. That's one of our goals here, is that we hope that people will use these. We have them for the different parts of the science exam.
So Eric,
yeah.
just say where they can find them.
Well, yeah, we'll be sharing a bunch of links at the end, but everything that we use is, we try and make available on Collect Ed New York. And so we'll have a bunch of links later. This is under a section, information about the TASC exam. And so you can see that they're under here. We have detailed descriptions for math, and each of these are fairly long Google documents, and then we have them for science as well. And a couple other documents, like what every teacher should know about TASC math, what every teacher should know about TASC science, wherever that's somewhere in this list too. But we'll post links here later in the session.
Yeah, so I'm just gonna say, Eric keeps saying we, but he created those, and I use them to create lessons, and they're just my go-tos now. They're so helpful.
Okay.
I really recommend them. Okay, so here is one little chunk of one of these detailed descriptions and sample items. So what I'm going to do, I learned by reading. I am not a science person. I learned all this when I was young and then forgot it. And then when I wanted to make lessons, I had to do a lot of reading, and I really relied on those detailed descriptions that Eric was just showing you. And I had to relearn some things. So what I'm going to do now is I'm going to read a chunk, and I'm going to ask you to just get pencil and paper and just take a few notes. I'm assuming that some of you are reading and writing teachers. As GED teachers, we have to be generalists. So just take a few notes while I read each paragraph. So the first one says, gravity holds Earth in orbit around the sun, and it holds the moon in orbit around Earth. The poles of gravity from the sun and the moon cause the patterns of ocean tides. The moon's and sun's position relative to Earth cause lunar and solar eclipses to occur. The moon's monthly orbit around Earth, the relative positions of the sun, the moon, and the observer, and the fact that it shines by reflected sunlight explain the observed phases of the moon. So how many lessons do you think you would need to teach what I just read to students?
I mean, if we were trying to teach everything in there, you could do a lot.
Yeah.
But if, that's often the trap I find myself in.
Yeah, it's a lot of
I think I might, I used to try to teach moon phases, for example, because that's also something you can really observe and see, but but in the interest of time now, I might focus on orbit and relative positions of heavenly bodies and us as observers on Earth. Like those two things and anything else that comes into those two things.
Right.
Personally, I think gravity and tides is fascinating, but again, sort of big picture, maybe orbit and relative positions.
Okay, and then I have Eve and Esther saying 4 lessons. Okay, so yeah, so this is sort of condensed, and yeah, it's a dilemma always. Okay, so next one. Earth takes 1 year to orbit the sun. The rotation of Earth takes 24 hours. Since it takes 24 hours to rotate 360 degrees, it takes 1 hour to rotate 15 degrees. The rotational axis of the Earth is tilted, which results in changes in the angle that the sun's rays strike Earth at a given latitude. These changes cause seasons, with the resulting variation of the seasons between northern and southern hemispheres. So again, a really big, a lot of information there, a lot of concepts to grasp.
Kate,
Yeah,
I find that with something like this, there's a lot of video available to this, and that cuts down the time that it takes to.
good point. Yes, definitely. Yeah. And then, so finally, Earth's coordinate system of latitude and longitude with the equator and prime meridian as reference lines is based upon Earth's rotation and our observation of the sun and stars. So it's a lot, right?
Yeah.
So that is what we are kind of, we're working on some of this in the lesson that we're going to demonstrate next. So Eric, why don't we go to the next slide? So this is the place we decided to dig in and start. Now we're getting into the lesson that we created, or part of the lesson that we created for students. And decided to start with this because I always like to try to start with things that students will probably know, because we have a lot of students who come from different parts of the world. So they've experienced this. And I wanted to have the globe because I feel like diagrams, visuals are incredibly important to really grasp the concepts. You need words and pictures both. And because I think that students will probably know things like the equator, at least. So next slide, please. And so one of the first things I will do with students is something like this, so they have some sort of visual and reference point. And when I teach any kind of mapping, so we pointed out, I think earlier, students need to understand northern hemisphere and southern hemisphere, and they may not really know about that. So I like to have something that's labeled and something that isn't labeled. And then if we're teaching online, I'll say like, okay, who knows what this line is? So someone may already know, but then they can also reference it. So that's how we start building some of the background knowledge that we think students need to start taking on the understanding of seasons. Any comments before we move on?
Kate, I like the diagram a lot.
Mhm.
Also, the word sphere is a math word. So
Ah,
a lot of these things you teach, in my group, we were discussing that when you teach general, earth science, you really can't segregate science into one thing. You're only also talking about math vocabulary, you're talking chemistry, you're talking, so science, even though we're trying to say, okay, these are the high priority areas, obviously when you talk about earth science, you're bringing in everything else under the umbrella. So eventually when you talk about earth science and how the sun hits the globe, you eventually, if you do photosynthesis, it's going to come up, and then you're going to deal with a chemistry kind of equation to show photosynthesis. So it's nice to kind of say, yes, we're starting with earth science, but we're actually extending out. When we teach earth science, we're doing more than that, is my point.
yes. I think that's a great point, and I think that we have to be willing to be flexible that way, to sort of, it's good to build enough of our own background knowledge that we know where those connections are. Okay. And so Vanessa says, would using this passage with all the parts students need to know as a reading passage and having students identify key points possibly help with chunking per student? Yes, I think that's a great idea. I don't know what other people think, but I like it. And does the GED test have released versions that can be used for practice? Oh, that's a really good thing to look into. All right, so let's move on. We don't have a lot of time. Okay. So is this a breakout room, Eric? Are we just talking about this?
I think we should just talk together.
Okay. So this would be a slide that I would give students. I might give it as 2 separate slides for them. We put it together for teachers. How many of you think that your students would be surprised by the picture?
I think there would be people that would be surprised.
Mm. Okay. So A. Andrew said mine would probably be surprised by the picture. And Eric says, what explanations would your students offer? Okay.
I guess my question, have you asked your students a question like this? Have you heard explanations about why is it warm in the summer and cold in the winter? Or
Yeah,
about why the seasons are reversed?
That's funny, Lakshmi. Okay, so Eve says usually they don't know that.
I think they might just make an assumption about maybe the equator,
Yeah.
that it's close to the equator, and that's about as far as they can take it.
So let's go to the next slide, Eric.
So these are some misconceptions that I've heard that are very common misconceptions about the reasons for the seasons. That the Earth is closer to the sun in the summer, or the Earth is farther from the sun in the winter. Sometimes people will know about the elliptical orbit of the Earth around the sun, and that the sun is closer to the sun at certain times of that during that orbit. But they are misconceptions. So why are they misconceptions? What's incorrect about these misconceptions? Or how do you respond when a student shares one of these?
I think I've had students who assumed this about the distance to and from the sun because the sun is a heat source. So they think that's like the most common thing I see, and more so than the orbiting issue. But I deal with lower level. Yeah.
Okay.
But it does seem reasonable in a way, right? That the Earth is farther away, so it will be colder if that's where the heat's coming from.
Yeah.
Yeah, like a fire.
So Lisa says the concept of the axis being tilted is a great mathematical idea that can be used to really examine how the sun and the Earth's tilt work together in different parts of the world at different times. So math becomes super important to understand.
And Eve mentioned the tilt of the Earth as well. So Eve, how would you redirect to the tilt of the Earth? If you're able to.
I think I I would just do a line of inquiry. So why do you think that the sun is, that the earth is closer to the sun? What is all the earth closer to the sun? Is it part of the earth? And if they say all of it, I'm like, well, it's colder here at that time than it is here. So why is that? What are some ideas we can come up with? And I would give a hint about angles. It's a great time to interject some math that maybe if I was really good, I would have taught the hour before, you know.
I think what could help with this is also the story of the birth of the solar system and the birth of Earth. And I think it's a great story on how Earth got tilted, you know, this story of how planets accreted from the material left over from the formation of the sun. And then also this drama that happened where a mini planet slammed into Earth, tilting her. And then all of my students were like, what's the name of that mini planet? Theia. And so it becomes like this really story of the birth of Earth and how she got tilted. So I think that's a fun story, but that it'll help them connect to these other larger concepts later to understand how did the Earth get tilted. So I think the reading component to science cannot be overlooked, and all the vocabulary involved is so critical. So I think getting to first this story, seeing it visually, there are great, of course, videos out there, PBS, Nova, but it starts, I think, understanding the story of the solar system.
Yeah, that's a really good comment. And it's interesting to see both of your approaches. They're both really, really good. And they're sort of a different way in. Yeah.
So Kate, I think you were going to talk about how you continue with the
So,
lesson.
I tend to do it more like Alexis, because I'm a reading person. I just depend on reading. My actual lesson has more reading. But I do think that when I think about this stuff, I want to present one nugget of one concept at a time. Because I know when I teach my students, they're so overwhelmed. They keep saying how overwhelmed they are. So just, one thing at a time. That's all. So Eric, let's go to the next slide.
So I think we're going to ask you now to take a moment and we'll do a quick notice and wonder. So looking at this image here and in the chat, could you share some things that you notice? Let's start with that. What do you notice when you look at this diagram? Eve notices that she has the diagram herself. So, what do you notice in the diagram?
A lot.
Light shines on the inside of the circle. That's a nice idea, right? The sun's on the inside and right. There's still a lot of information in it. The North Pole is consistent. Every image has North and South hemispheres. And 4 seasons. Lakshmi, you said the ellipse is because of our point of view. What do you see that makes you say that?
So this is based on confusions that have come up with my students. Like, we know that that's what it is, as opposed to that the Earth is orbiting around the sun Like if this was north and south, that the earth at the top of the picture is north of the sun and the earth at the bottom of the picture just to the lower right of the sun is south of the sun, but it's not really like that. We're actually trying to show it all on a level plane and it's going around it, you know, this way as opposed to that way. I don't know how to explain it. I do know though that even when I've done it in class, like as a demonstration with a lamp and, you know, somebody's the sun and somebody else is the earth and they're rotating the sun and the whole thing, like where you have shadows, and it still doesn't, it doesn't make sense to a lot of students because I'm presenting an explanation of this is the way things are. And so I haven't yet figured out how to help students figure out why is this the way it is rather than model and explain this is the way things are. Does that make sense?
Yeah.
Like, you know, when you demonstrate, when you model this, like with the sun in the middle and the earth going around, or you show a video or you show a diagram like this, you're explaining this is our accepted explanation for the way things are, the tilt of the earth and the reasons for the seasons. And a lot of students have a really hard time with this. And I'm wondering if there's a way to kind of like the flat earth people, that documentary, figuring out that the earth really is round, like they talk themselves out of their own explanation. Is there a way for students to figure out this rather than try to grasp an explanation?
Well, that actually leads us to a nice next step. Can we start to share some questions? What do you wonder? So I'm gonna write my understanding of Lakshmi's question in the chat. Is there a way for students to come to this understanding? Is that right? What could we show them? Instead of accepting our explanation, is that right?
Like that, yeah. I mean, it's like they're sort of taking on faith that this is the right explanation, right? So what can they, yeah, exactly. Thank you.
It's also understanding this picture, like we're looking at it as if we're a deity looking in, right?
Yeah.
And
Right.
then what happens if we make ourselves the sun? How different will that picture be?
Right.
Or if we're standing on the planet. This diagram has a lot of information, but the viewpoint is the thing. Like we're peeking in to see this kind of cosmological happening. So that's what makes it a little funky.
So I'll just say Eric wanted to take out the info and I said no, because I'm a reader and I want words. You know, either way, I mean, for me, like I can focus on one thing here, winter in the Northern Hemisphere, and look at this and it helps me. But, you know, some of you may want to do it differently. And Erna said, yes, she agrees with Eric.
I also wonder, because the idea of looking out and looking in, I wonder, you know, there's the story of the first image taken of the Earth from space, you know, by the astronauts, and like starting with the fact that we never had that image before, that those of us who are, you know, maybe born in the 60s, like I was, grew up with that image, but people who were older didn't have that image until after the astronauts went into space. And that's, you know, another story, another way of coming in.
Yeah, so Vanessa, that is a nice idea, matching words and images. Yeah. And also a great review activity. After they've done this, maybe seen a video, done some other work with it, read about it, then come back and do that again. And, so yeah, before and after would be nice.
And it's interesting, and a number of people are, you know, keep reminding us that the questions on the exam are often about why things are true, right? So understand why, not just what, is an important thing. I'm going to show you another simulator we've used with a class recently. Let me see here. So this is a frozen image of what it looks like in the link, which we'll share later. Let me see here. I'm going to share this in a way that helps everyone see it more easily. Moment.
Eric, is it possible to make it a little bigger?
Yeah, just a second. So I'll show you what we did with students first. I believe we started like this. Is that right, Kate?
Yeah.
And we did a what do you notice activity with the simulator, and we could pause it. Let's see if we can try and find today's date. It's moving pretty quickly. What is today? Oh, I missed it. Not too far off though. Anything you notice about today's date? I'll give you a little bit more information. Let's run it around again and then see if I can get a little closer. What's today? May 15th. Ooh, not bad. Okay. What do you notice?
Mhm.
Kate notices that the North Pole is in light. South Pole is not. A good question. Lakshmi's asking about outer space. This is an outer space point of view. Is there something similar from the Earth's perspective? It's a good point. So then we kind of slowly, we spent more time, but we slowly revealed more information on the simulator because it seemed it was a lot to take in at once. And I'm not sure how much time we spent on these up graphs down here, but what do you notice as teachers?
So Eric, can you go back to the, without all this other information, just the,
Sure.
yeah. So yeah, stop. Like, I think it's good to also look at winter in the Northern Hemisphere.
Mhm.
Yeah.
Oh, Christmas, look at that.
It's nice that the distance, you'll notice, changes as the little radii goes around. And that even though this is a circle, those numbers are different. The distance from the sun to the earth keep changing. And maybe that's a way also to get back to that, dispelling that myth. Oh, we're closer to the sun in summertime, when they can actually see that distance. And I guess a discussion about AU and is important. And someone will ask, what is that AU stuff? And also that they're representing Earth's orbit around sun as a circle, but those numbers are telling us maybe it should be another shape. So maybe that's another discussion.
An ellipse, yeah.
What's interesting, it's an ellipse, but the ellipse that they show in books is much too exaggerated, right?
Yeah.
Isn't it? Because the
Numbers are very
difference between 1.05, 1.015 and 0.983 is
Yeah.
not that much, right?
I mean, when you stopped at Christmas, it seemed to me that would be a good place to talk about why can you go to the beach in Australia on Christmas? You know, that I would want to connect those two things.
This is maybe a moment to say one thing that I don't think we've really figured out was how to, I mean, what is it about the tilt of the Earth that makes this situation warmer for the southern hemisphere?
Right.
It explains why the South Pole, like the sun doesn't set, but why is it hotter here?
Right.
Like it's about the angle of the sunlight, and we looked at some explanations, but in the end we didn't really linger on it because it felt like like you take a flashlight and you shine it straight down on a piece of paper, or you shine it at an angle and the sort of light is spread out. But it's I don't know, it seemed like a concept that was difficult to explain and understand about why the collection of the heat in a more direct, straight up and down, like why that transfers more heat than at an angle. We didn't solve that, I don't think.
Although you could link it to night and day, and why are you going to more likely get a sunburn at noon than at, 6 o'clock?
Right. Just,
Let's look at the full thing now with all of the bells and whistles.
oh, you want to go? Okay, okay, we can do that.
Yeah. So I want to say in our original lesson, we also talked about the length of the day in winter and in summer. We didn't want to bring that in for this because we had so little time. But I think that I like this bottom part too. It does talk about the angles.
Yeah.
So I'm curious if any of you would think to use this in your class and any approaches that you might take if you did use it. Okay, Vanessa says, yeah. So Rebecca says it makes it more complete. Vanessa says, I think it would really help visual learners. Yeah, I mean, you can focus on one thing at a time, like hours of the day on the equator. Why is it going up and down? You can stop it.
It's interesting just to see the length of the day in the Arctic, right? 'Cause these are the hours of the day. In the summer, it's light. You can see the light intensity the whole day. And then when it gets around, it's down to nothing the whole day. It's interesting.
Wow.
I'm going to reshare and go back to our slides, Kate.
Okay.
Can I ask a question?
Yes, please. Go ahead, Lisa.
Oh, I just wanted, this is a teaching question, which is that I find that my students, a lot of them don't have the patience to really come in on specifics and details, very difficult. So I find myself teaching in generalities and test approach, because I find that I can spend a lot of time breaking something down with visuals, with text, with conceptual models and so on. And the next week they have lost it all. So, I find myself trying to find what is the general concept and keep hammering away at that general concept and hope that they can hang on to it and apply it in a couple of different ways and just keep circling back to it, as opposed to trying to really delve into something like like what this really means in terms of seasons and, you know, what the bigger implications are.
So I'm going to say something about that. I mean, it's a dilemma. I absolutely don't want to say that I have answers. My approach is to just do it again and again,
Right.
give review in different ways. And someone said earlier about vocabulary. For this one, I'm not completely sure that vocabulary is the big deal. For life science, I think it is. I think earth science is very, very visual. And, you know, so repetition, a lot of repetition.
Yes. That's what I do too. And I do the same thing as you, Kate, which is I rely a great deal on reading. So I present the same concepts from as many different sources as possible, so that they can see it written out with different language, but same idea.
Yeah. And now, would a pair and share where learners have to teach it to each other working your environment? I think that's an excellent idea. You know, I know one program I work at set up a Zoom so students can just have study groups and they can go on anytime. I'll meet you there at 3. I think that's really a good idea because this stuff is it's very overwhelming cognitively, I think. So study techniques, especially when we're learning online, I think study techniques are even more important.
Can we look at the review idea, Kate?
Yeah, sure. So this is one thing that I do with students always, and they like it because it's graspable. So I always do an initial review that's like a close. And they can go back to the text and check.
And when do you think about when you're writing one of these? Are you thinking like, you know, what are the main ideas and
Yeah, I'm writing a summary in plain language of the main points and then making it into a close.
it seems like it's sort of it maybe is a way of in lesson planning that you start out with a very, you know, like a couple paragraphs. It's a summary of what you want students to understand by the end.
Yeah.
Use that. Some of it ends up in your reading, in your text for the class. You also have some diagrams or simulations or something, a video, and then come back to that with some of the vocabulary pulled out and mixed up, so that it's a very supported way to do a review. I mean, I think the idea is the students are going to get every one correct, pretty much. It's not like an incredibly challenging task, but it gives them a chance to think through it again, right?
So Vanessa, can you talk about 5-star cards? I've never heard of it.
5-star cards is basically making a study game out of flashcards. And once a student gets this card right, they would put a star on it, put it back in the deck. And as soon as this card hits 5 stars, they move that to the side and they keep going until they have gone through all the information.
I love that because it's low tech. Yay!
Yes, and Kahoot is more of a high tech where they can weigh in, they can they can make up a participant name, and that way if they miss a question, they're the only one who knows that they got it wrong because they know what their username is.
Right. I think that's great. I love that. Thank you for that idea. Yeah, so I think we could look at the descriptions. I think, Eric, if you don't mind, maybe we can look at this lesson as it was a lesson plan so people can see how much reading there is, because people were asking about that.
Yeah, so I'm gonna just real quick, just so everyone has it, I'm gonna put a bunch of links in the chat to the things that were, we'll also put a link to our slides there in a moment. Let me see here. So we just posted Kate's lessons. Am I sharing the right thing? Okay. On Collect Ed. So again, this is the website we use to publish our materials. Just put it in the chat. So this is there's a link here to a Google folder. And these are the 6 lessons. Did you want to look at this lesson, Kate?
Let's look at lesson 2, yeah. And, I want to say, when you see it, you'll say like, okay, this is written by an insane person because there's so much information. But I would recommend that you take parts out, that you chunk it. And the way that we taught this was we had a lot of students in the class and we did breakout rooms so we could have just 10 students in each breakout room. But you'll see that it's mixed, because people had asked about reading, that there's a fair amount of reading here. So it's really intended to be something you teach, but then they have the text and the whole lesson, and they can keep going back to it and study it and rewatch the videos and look at the diagrams again. So there's a lot in this lesson. There's shadows. So it's, I would say it would be could be quite a few days. And just stop there, go above. There we talked about the angle of insulation. So I do think when you teach the lesson, it's really necessary to have that. So, all right. So those are there for you to use.
I'm sorry, Kate, just want a quick point. I'm not sure how familiar everyone is with Google Docs, but these are view-only links. But when you open it up, I guess it won't look quite like this because you won't have an edit version, but you can always make a copy. And then you're working with your own, and you can make changes, you can delete stuff, you can add stuff in there, and it becomes yours. Or you can download it maybe as a Word document, and you can edit and make changes and that sort of thing. We're going to keep working on these a bit. I mean, this is a draft from after Kate taught it, right? This is directly out of your class, and actually there's places where I think there's some answers from your class that we wanted to pull out. So it's a little bit of a draft right now, but we're going to keep working on it, right? But I really appreciate Kate because she dove in and she made sense of a lot of the earth science topics in a set of lessons that she taught with students. So it's a work in progress, but but she's sharing.
Yeah, but I couldn't have done it without those detailed descriptions. So I think the two things are very good together. So Kate is telling me there's 5 minutes and there's an evaluation that you have to fill out. So Kate, let us know what you want to do.
Sure. So I'm going to put a link to an evaluation. It is a Google form in the chat for everyone. And we would really appreciate if you could fill that out and give feedback on this session and any other parts of the ABE conference that you participate in today. That would be really helpful. There is we ask that you do a separate evaluation for each thing that you participate in, just so that they can be kept separate. But any remaining questions for Kate and Eric? We have 5 more minutes and we do need to end on time.
Okay. All right. I don't see the link for Kate's lesson. I'm blind. So that's it right there, right, Eric? The last thing there.
I'll put it in the chat again. I'm sorry, I'm dumping a bunch of links. Here's Kate. Yeah, we can share the slides as well. Stop sharing now, but we will share the slides for sure. They'll be view only, but you can copy them.
And we did record this
Download them.
session. I believe that will be available as well, probably from the ABE conference planners later on this week.
So any other final thoughts or ideas? One thing I'd like to mention is if, Kate shared her lesson here, if anyone else is interested in sharing a lesson that you've written, a science lesson you think that would be good for other teachers, we'd be happy to share those lessons through Collect Ed. We have a section for distance learning lessons. And we'd love to share your lesson if you're willing, if you have, readings or stuff you've made sense of.
This was fantastic. You made me excited about trying to get more detail. Thank you.
Well, if there's no other questions or comments, I just want to say a huge thank you to Kate and Eric for presenting this morning. This was wonderful. Eric put a whole bunch of links in the chat. Hopefully you all were able to click on that. But again, they are also, most of that is at Collect Ed New York. And if you need any other information about that, feel free to email the conference hosts. I know that they're going to keep track of all those links as well.
Yeah, if you want to reach me, that's my email. If something's broken, you want to know if I have some resource about something, anything. And yeah.
I'm going to put the evaluation link one more time in the chat. Again, we'd really appreciate if you would fill that out. And with that, I think we have to close it up.
Right on time.
Thank you. Thank you very much.
Thanks, everybody.
Good seeing you.
Thank you all.
See everyone. Okay.
Bye-bye.
Bye.